Hello, chemistry students. This is Mr. Martin. Today we were going to review accuracy, precision, measuring, and significant figures, which you learned last time as you watched a video. Then, once we reviewed those topics, we will talk a little bit about scientific notation. For some of you, scientific notation will be a review of previous life learning. For others, this will be brand new information. I did not put together a lecture guide or a notes page for you to follow along with, so this time you're going to want to write a few things down as we go through this PowerPoint. If you're in first, second, or third period, as you watch this, I am still in the Zoom meeting. So if you have any problems or questions, just pop back over to the Zoom and feel free to ask. Fourth and fifth periods, since you started this with a substitute, I will be at office hours beginning this afternoon at 1 o'clock if you need me. So let's go ahead and get started. Maybe. There we go. So last time in the video about accuracy, precision, and significant figures and measuring, I had you take some notes and turn them in as an assignment. A lot of you didn't actually fill in the blanks the way that you were supposed to or draw the pictures that you needed to. So for now, I'm not going to deduct any points, but in the future, if I do decide to collect your notes, you'll need to do a better job and make sure that they make sense. Don't just go through and fill them out thinking that, well, I can just fake it. If you didn't actually watch the video, then you're not going to get full credit for taking the notes the way you should. All right. So in that video, the instructor defined a few terms. So to go over those terms, remember accuracy is getting close to an accepted value. How accurate are you? So if the value is supposed to be 100 and you get 98, that's considered pretty accurate. But if the answer is supposed to be 54 and you get 27, that's not very accurate. All right. Precision is repeatability, or another way of looking at that would be more digits reported as we measure that substance or that length of that item. Okay. Precision is repeatability. In order to get better precision, you need a better measuring device. The video that you watched used a ruler, and they said to estimate one digit beyond the markings on the tool. That means that you need to use one more decimal place than they showed on the device. The same would be true on any measuring tool, not just a ruler. The tools that we used were these. We used a triple beam balance, or the ones that we would use, that is. We use a triple beam balance for weighing something's mass or its weight. We would use a graduated cylinder to measure volume. Volume is how much space something takes up, usually for a liquid. A thermometer would measure temperature, and a digital balance or a digital thermometer for any digital device. We'll talk about this in a moment. The uncertainty is built in, so you would just write down whatever is shown on the display. You don't round it, you don't estimate anything else. What it says on the screen is what you write down. Some of you may have a digital scale at home that weighs how much you weigh. And for those, you don't round it. So if it's 196, then you're 196 pounds, not 195 or 200. You write down whatever's on the display. We'll come back to that in a few minutes. So one of the tools that we use very often is called a triple beam balance. I think a lot of you may have used these in your middle school science class. For these, there are 3 beams. And once you place the object on the pan, so you would place it, I don't know where this is going to go, maybe over there. See, that's not what I wanted to do. Go back. If you place it on the pan in this general area, then the balance is going to go up. Okay, this little line where the circle is and the blue arrow would not be 0 anymore. When you put the substance onto the pan is balanced. You put it on the pan over here and it goes donk and it goes up. So it would be too heavy. So the way that you would use this is you would begin to add weight to the balance until it becomes balanced. We would begin with the hundreds weight. On this one, you can see it's in the middle. There's not very many markings. These little notches are actually where you would rest that weight. You would move the hundreds weight into the first little mark, which you can't see it on this balance. It would say 100. You'd move to the next one for 200, 300, 400, and 500. For this specific balance, you'll see that it maxes out at 2,600 grams, 5 pounds, 2 ounces. But again, you wouldn't be able to measure it without zeroing it out ahead of time. This is kind of fancy. So again, we can measure 1, 2, 3, 4, 500 grams. And then what you would do is once you have gone too far, so let's just pretend our substance weighs just over 300 grams. So we move it to the 100s notch and nothing would happen. We move it to 200, nothing happens. We move it to 300, nothing happens because it's a little bit more than 300. As soon as I go to the 400s mark, that the balance part over here would then go down. Sorry, I'm not ready for that. So again, we get to hundreds and it would go down when we get to 400. So we would back it up back to the 300, and then we would move to the tens weights. So again, on this balance, you can't see the little 10 weight. It's this back beam. You can see all those little notches that are back there. Those little notches, let's see if I can point at them. I don't know if you can see this. These little notches are every 10. Okay, so you had been at 300, and then you start moving the tens until it gets a little bit too heavy. Then you back it up to the previous one. And then finally, we use the ones weight. The ones weight is the one that contains all of the precision, all right? We would slowly slide this one over until it gets to the weight that we want it to, where it becomes balanced. And then we would read our overall weight, okay? So for this specific balance, it is going to be measured, let me say that differently. The markings are to the nearest 10th of a gram. I don't know if you can see that. So there are 1 is the big numbers. Again, ones are here, and there's little 10th marks as well. So we should be able to read this to the nearest 100th place, 1 estimated decimal further. So let's look at one with an actual measurement up close. So for this, you can see all three of them from a different angle. Here's the 300 weight. Like we talked about, it's a little bit more than 300. If we had gone to 400, it would have gone too low. So we backed it up to 300. Then we slowly moved the tens, and we got it to 70. And then at that point, we see that it was still too high. If we went to 80, it went back down. So we back it up to 70, and then we slowly moved our little slider. I know the image isn't super crystal clear, but you can see that this is 373 point. And then for me, I said it went beyond the 0.3 mark and between 0.3 and 0.4. So I'd call it 373.35 grams. Okay. For volume, we're going to use what's called a graduated cylinder. Now, technically, these two items on the right-hand side are called beakers, but they have graduation marks, so we could use them. For our class, beakers are usually for estimating. If we ever get back into in-person, we would use beakers to estimate, and we use graduated cylinders to actually measure volume. So again, these are all the same amount of liquid. You'll see that this is just under 10. It's like 9 point something, just under 10. Let's go over here. Just under 10, just under 10, just under 10. And this is a 10 milliliter beaker, and it's just under 10. So again, we're going to use that to measure volume. However, we need more precision than that. So what ends up happening is when the line in a graduated cylinder becomes full, the liquid bends. It has a fancy name. It's called the meniscus. And we always read the value of the volume at the bottom of the middle of the meniscus, which on this would be right in here, okay? Right in that area is where we would read it. So this graduated cylinder is being measured to the nearest 10th. Sorry, no, it's 0.2. Each mark here is 0.2 milliliters. So for this, our estimate is only going to be able to do that 1 decimal place. So we can see that it's between 3.4 and 3.6. So for me, I would call this 3.5 milliliters. Notice again, it is not 3.50. 3.50 is measuring a little bit more precision, and we don't have that ability. All right. Thermometer, we can see the same thing. On this tool, it's measuring to the nearest 10th of a degree. So when we read it, we can actually read 1 more decimal point than it is showing. If the little black line inside of the orange portion of this were the liquid in the thermometer, we would read this as being 37 point, and again, as we look up here, 37.1, 2, 3, 4, and then we have to estimate 1 more digit beyond that. So I say it's 37.4. I'm going to say that that's right on the line. Somebody else might look at this and go, Mr. Martin, I don't think you're right. I think it's a little bit beyond that 0.4 marking. I'm going to call this 37.41. That is completely acceptable. That is the last digit is what's called the uncertainty of the measurement. And everyone's going to get a little bit different of a value. All right. So now back to digital substances. This is a digital device. And for digital devices, the uncertainty or that last estimated digit is already included by the device. So if I were to measure this powder that's on this piece of paper, we would call it 16.43 grams. However, we have another question that we would have to ask somebody that was doing this. Did you subtract off the mass of the paper? If you did not subtract off the mass of the paper, then you get to start all over. However, a lot of times there will be a button on the digital balance that you can push that says either tare, T-A-R-E, tare, or 0. And that is when you put the measuring container onto the balance, you push 0, and now it knows to not count the weight of that substance. So in that case, we would be weighing just the powder. So again, here is our problem. COVID strikes again. If we were in person, at this point, we would have stopped in class and you would be getting to do a lot of measuring technique. You would get some graduated cylinders, some triple beam balances, some other measuring tools that are specific to chemistry, and you would measure some things, and I'd make sure that you're measuring them the right way. But for now, you don't get to do that, so we're going to move on. You will have an assignment on Wednesday afternoon that will include looking at measuring devices and making sure that you read them with the proper level of precision. So as we move on, what about scientific notation? I'm going to go through this a little bit faster because hopefully you already know a little bit about scientific notation. It helps us to communicate our ideas. Small and large values end up being difficult to write because there are a lot of zeros included. So what we're going to look at is a way to write these very large or very small values very easily. It is a number between 0 and 10, and that number is always followed by an exponent. So the exponent is what is going to move the decimal point around. If it is a very, very big number, then the exponent is multiplying that thing by 10. The other thing is a positive exponent means that value is greater than 1. If it's a negative exponent, that value is less than 1. And as you recall from the video before, any digits that are being written need to be considered significant. For significant figures, we only look at the digits before the exponent. So that would be like if I had 2.46 times 10 to the 6th, the 2.46 are all considered significant. The exponent is not significant. The exponent only tells you how many times we need to move the decimal place around. For Moodle, just so you know, we're going to use the letter E in place of the number 10 or times 10 to the. So again, on Moodle, if the value I wanted to enter was 1.23 times 10 to the 4th, I would enter 1.23 E4. Right? That E is replacing the X and the 10 for the times 10 to the. Right? So let's look at this again. Let's just look a little bit more about what's going on. Larger exponents. The larger the exponent is, that means there are more zeros included. If it is a positive exponent, we are multiplying by 10. If it's a negative exponent, we're dividing by 10, and we're moving the decimal place left. So here are two examples. If a value is 1.25 times 10 to the 5th, what we're really saying is we've measured this to the nearest 1,000, and we need to hold the place value with only 3 significant figures. So it's 1.25 times 10 to the 5th. And so we would assume or kind of imply that there's a decimal right here after the 0. And so we would need to move it 5 places to get 1.25 times 10 to the 5th. What about a number less than? That would be 8.25 times 10 to the negative 6th. I put spaces in here so you can see the zeros a little bit better. That's 3 zeros, 2 more zeros than 825. So we've moved the decimal place 6 places. So you ready? Here goes 1, 2, 3, 4, 5, 6 decimal places to 8.25. And since it's a value less than 1, that is a negative exponent. Again, on Moodle, we would write both of these with an E instead of times 10 to the, and then you would just use the exponent -6 or +5 to be able to do that. All right. So you need to be able to recognize which values are smaller and larger. In the assignment that you're going to be doing today, it's going to ask you to classify which values are larger, which values are smaller. So you need to be able to recognize those things. All right. So the assignment that you have is actually called Scientific Notation Quiz. Actually, it's not called quiz, it says Scientific Notation. But remember, Moodle calls everything a quiz. This is your assignment to be working on today. It's due before you come to class on Wednesday. I will be available Monday during office hours for those of you in first, second, and third period, and I will be available in the office hours for fourth and fifth period on Tuesday. First, second, and third period, if you need help, I will still be in the Google meeting, actually the Zoom meeting for first and second and third periods, so you can pop back in if you need to ask any questions. If you don't work on it during that time and you need some extra help outside of those hours, send me an email. I will respond as soon as I can. Again, remember that between 7 and 3 in the afternoon, 7 p.m., 7 a.m. and 3 p.m., I will reply to emails almost immediately. After that, then you'll probably wait until the next day, right? If you have any questions, please, 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 you have to ask. I'm not able to look at your face to see if you're confused or not, so I would love to hear from you if you are struggling. That is the end of this video. I will see you next time during our class live session. Have a wonderful, wonderful day.